Namaste friends, welcome to my channel Prep for Mechanical. Today we will discuss Hooke's law, tensile test, stress strain graph. Let's start. Hooke's law. Hooke's law is also known as stress strain law. According to this law, stress at any point in an elastic solid is a function of the strain at that point. Is that within the elastic limit, stress is directly proportional to strain. So the ratio of stress and strain is always constant, which is called as elastic constant, also known as Young's modulus. Here E equals to Young's modulus. This relationship is determined by experiment through standardized lab tests. The most common and popular test is tension test or tensile test. In this test, a standard dimension specimen, also called as test coupon, is used. The dimension of test coupon may vary from organizations to organization who sets the guideline for the test. Here I will take an example of ASTM E8/EDM08 test specimen. This is an image of pin-loaded tension test coupon. In this image, G is gauge length, W width, T thickness, R radius of fillet, L overall length, A length of reduced section, B length of grip section, C width of grip section, D diameter of hole for pin, E edge distance from pin, F distance from hole to fillet. So the cross-sectional area AG equals to W into T. So stress equals to load P and cross-sectional area AG. The test is conducted on universal testing machine. The specimen is gripped in this machine for tensile testing. The machine gives load at different situations and stress is determined by dividing load with cross-sectional area. This is an image of universal testing machine. The specimen is gripped between upper crosshead and movable crosshead. When load is applied, adjustable crosshead moves downward and tensioning of specimen happens. The load is measured by load cell. The strain is measured by strain gauge mounted along the line of axis of gauge. This is an image of strain gauge. Two strain gauge is used, one for longitudinal strain measurement and other for lateral strain measurement. The experiment is done for different load setting and a set of value for stress and strain is obtained. This is an image of stress-strain graph. A stress-strain diagram is constructed by plotting strain along x-axis and stress along y-axis. Its shapes depend upon material being tested. This is how stress-strain graph is obtained. The diagram exhibits four distinct zones: a linear zone, a yielding or perfectly plastic zone, a strain hardening zone, a neck zone. Elastic region. In this region, stress and strain are linearly proportional to each other. This region is elastic because the original shape and size of coupon are restored upon removal of load. In this region, proportional limit is the upper limit of stress inside the linear elastic region. All the calculation in strength of material is confined to the elastic region marked as A. Yielding zone. A stress value slightly more than the proportional limit is called elastic limit. The material is elastic in this region bounded by proportional limit and elastic limit marked as A and B, but curve becomes nonlinear. Beyond this limit, material deforms permanently. The minimum value of stress that initiates the permanent deformation is called the yielding stress, marked as B. Upon the initiation of yielding, the strain increases up to a point C without any increase in the stress. The region behind B and C is referred to as the yielding or perfectly plastic region. Strain hardening zone. Due to dislocation movement and dislocation generation within the crystal structure of the testing coupon, pink shaded region shows strain hardening zone. It begins to harden beyond the perfectly plastic region, marked by C and U. This phenomena is referred to as strain hardening because stress increases with strain. The stress and strain relationship is nonlinear in this region, which extends up to peak stress point U referred to as the ultimate stress. Necking zone. In this image, green shaded region shows necking zone. At about the ultimate point, the cross-sectional area of the coupon begins to decrease in a localized region. This phenomena is called necking and it continues until the specimen breaks at a stress value referred to as fracture stress marked as F. Fracture stress is lower than the ultimate stress. In this zone, strain increases, but stress decreases. Yielding zone, strain hardening zone, and necking zone combined referred to as plastic zone. Thank you for watching my video. Please like, share, and subscribe for more videos. Thank you. And don't forget to give your valuable feedback.